Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. So, we are in the lecture series of Analog and Digital Communications. In the previous lecture, we learned Introduction to Communications, nothing but what are the elements of communication systems, what is the importance of the communication, what the blocks of the communication system consists. These all the things we learned in the previous class. Right now, very important thing, very important for communication point of view, that is the today's topic. The topic name is modulation. So, what the topics we discussed today is, the first one is introduction to modulation, and the second one is types of modulation. Without knowing of the modulation, then we are not clear how the information can be passing from transmitter to the receiver. So definitely modulation is an important term in the communication system, in analog communications as well as in the digital communications. Then what is modulation? What is modulation? Remember, basically, once observe my voice, in some points, my signal strength is more, in some points, my signal strength is less, in certain points, having some medium range. Simply, this is one example of the modulation. But defining practically the modulation, definitely you need to understand two signals. What are those two signals is message signal and carrier signal. Observe, the first one is message signal and the second one is carrier signal. We need to these two signals. What is message signal? Remember, to define the message signal as well as carrier signal, we have called some other names. Those names are called as low frequency signal and high frequency signal. Observe, the first one is low frequency signal and the second one is high frequency signal. Low frequency signal and high frequency signal. I am using the word the low frequency signal, it is also called as a message signal. The high frequency signal, it is also called as a carrier signal. Why it is called as the low frequency signal as message signal? Why the carrier signal as high frequency signal means? If I am talking something, this is the voice signal, the frequency range of the voice signal in terms of hertz and kilohertz, nothing but it is a low frequency. But this is the actual information. So, I need to transmit this actual information to certain long distance. I need to transfer this low frequency signal in terms of hertz and kilohertz signals to the long distance. Is it possible with the low frequency? Without any supporting of the signal to transmit the long distance means it's highly impossible. Then you need a support signal. That supported signal is a high frequency signal. It does not consist any information, but it is helpful to send a low frequency signal or our voice signal or our information signal to a long distance. To a long distance. That is the main importance of the carrier signal. Here, my conclusion of these two signals is, the message signal consists the information what the user transmits from the transmitter to the receiver. But the carrier signal, it is a high frequency signal. It does not consist any information, but it is very useful to boosting the message signal. Nothing but the message signal can be combined with the carrier signal, then it is possible to transmit the signal to a long distance. Then How to represent the low frequency signal and the high frequency signal graphically? Very important thing. Then we have one small relation. What is this? The time period or time is inversely proportional to the frequency. The time is inversely proportional to the frequency. Nothing but once the time period is increased, the frequency is decreases. If the time period is decreased, the frequency is increases. Therefore, we have the relation once the time period is inversely proportional to the frequency. Then observe the first signal, low frequency signal. I am representing graphically here. For example, here I am taking in x-axis t. In y-axis, I am representing amplitude. Observe here, I am starting with 0 and ending with one cycle is 2 pi, and this is pi and 3 pi, like this. And I draw one more signal. Observe here, this is t and this is amplitude, but my representation is like this. Then see the two waveforms, the first waveform and then second waveform. Observe here, in the first waveform, the time period is more between the cycles, and here the time period is very less between the cycles. You know the logic. The time period is inversely proportional to the frequency. Then observe here, the time period is less means automatically the frequency is more. Therefore, this signal is a high frequency signal. This is a high frequency signal. Then here, the time period is less means whatever the frequency is. The time period is more means what is the frequency? The frequency is less. Then this is the low frequency signal. Graphically observe here, the high frequency signal representation, it is also called as carrier signal, and the low frequency signal representation, it is also called as a message signal. Graphically, the difference between message signal and carrier signal should be like this. The message signal is also called as low frequency signal. It is also called as information signal. The carrier signal, it is also called as high frequency signal. It is used for supporting to the message signal. Then once you have clear idea about the message signal and carrier signal, then it is very easy to define or to understand what is modulation. Then observe here, the next one is the definition of modulation clearly explains it is the process of varying the characteristics of high frequency carrier in accordance with instantaneous values of the modulating or message signal. Very important definition. What is the definition of modulation? Simply, it is the process of varying the characteristics of high frequency carrier. Remember, what is the high frequency carrier? The high frequency carrier signal, it is also known as carrier signal. It does not consist any information. But what is in accordance with instantaneous values? Remember here, what is the meaning of instantaneous values? The instantaneous value should be either varying in terms of amplitude, varying in terms of phase, or varying in terms of frequency of modulating signal. Remember, this is very important. The message signal is also called as low frequency signal, and it is also called as modulating signal, and it is also called as information signal, and it is also called as baseband signal. These all are other names to the modulating signal or a message signal. But the definition is very important. The high frequency carrier signal, remember again I draw repeating the high frequency carrier signal. This is the high frequency carrier is varied according to instantaneous values of message signal. You know the representation of the message signal is, this is the message signal. What I told? The high frequency carrier signal, this is the high frequency carrier signal is varied according to instantaneous values of, here the instantaneous values means first case I am taking the amplitude levels. That means this carrier signal is varied instantaneously with respect to message signal. Remember, the inner wave should be, this is a carrier, and this wave is thick line should be a message signal. Therefore, both are combined. But which signal having actual information means the message signal. That is the low frequency signal. Then you need to transmit that low frequency signal to the 100 meters or 200 meters or 1 kilometer distance. It is somewhat difficult. To avoid that, we need a support signal that is called as a carrier signal. Then it is defined in another way also. It is a frequency translation technique which converts baseband or low frequency signal to band pass or high frequency signal. Clearly observe, we are taking the low frequency signal. Clearly mathematically observe one thing. For example, I am taking 2 kHz input signal. So this is the low frequency signal or a message signal. Then I am taking the high frequency signal should be, for example, 100 kHz. So what is the low frequency signal? It is the 2 kHz. What is the high frequency signal? It is 100 kHz. Once you can combine, that is the definition of the modulation. What is the definition? The high frequency carrier signal, nothing but 100 kHz carrier signal is varied according to instantaneous values of the message signal. Instantaneous values of message signal. That means actually 2 kHz, when I am multiplying with 100 kHz carrier signal, the total signal should be equal to 200 kHz. 200 kHz, that means 2 kHz should be 200 kHz. That means automatically what is the definition? It is a frequency translation technique which converts baseband or low frequency signal to band pass or high frequency signal. Therefore, 2 kHz low frequency signal, it is converted to 200 kHz signal, nothing but a high frequency signal. This process is called as a modulation. This process is called as a modulation. Very important. Again, simply the definition. Observe here, the high frequency carrier signal is varied according to the instantaneous values of the message signal, that is called as a modulation. That is called as a modulation. Then, what are the types of modulations? What are the types of modulations? First, we have some idea about the modulation. Modulation is happen means need two signals. With respect to that knowledge, the modulation can be classified or categorized. The first one is a continuous wave modulation. The continuous wave modulation, it is also called as analog modulation techniques. And the second one is pulse modulation. Continuous wave modulation and pulse modulation. Remember, once you observe the definition, instantaneous values of, what is the instantaneous values? Already I told. The instantaneous values are nothing but amplitude, frequency and phase. Therefore, observe, we know the amplitude. Observe the waveform. I am taking a sinusoidal waveform here. Amplitude means this is called as a amplitude, positive side. And what is the time period means? The total complete cycle time period means this is a time period. Once you know the time period, automatically you know the frequency also, because the time is inversely proportional to the frequency. That means amplitude, one instantaneous parameter, value of the waveform or characteristics of the sinusoidal signal or any waveform having amplitude levels, and frequency or time, because once you know the time, automatically the frequency you know. After that, phase angle at 0th level or shifting from positive side to negative side, how much angle should be having, that is called as a phase, theta. The instantaneous values are amplitude is 1, time period or frequency is second one, and third one is phase angle. With respect to this variation, the modulation can be categorized in the type continuous wave modulation and pulse modulation. Again, the continuous wave modulation can be categorized amplitude modulation and angle modulation. Amplitude modulation and angle modulation. What is the meaning of amplitude modulation? Only the amplitude values are varying. The carrier amplitudes vary with respect to the message signal as per following the definition of the modulation. That is called as the amplitude modulation. In coming lectures, I discuss very clearly individually the topics amplitude modulation, angle modulation, one by one. But in this case, the total categorization need to explain. That's why I am giving the outline. Amplitude modulation means only the amplitude level should be varying. The carrier amplitudes is varying. Already I shown in the previous slide. Observe here in this diagram, the inner waveform should be carrier signal is varied. Here one amplitude, here one more amplitude, here one more amplitudes. Therefore, the amplitude of the carrier signal is varied according to the message signal. According to the message signal. That's why it is amplitude, that is known as amplitude modulation. Then go for the next one is angle modulation. Remember, the angle modulation, it is again categorized into two ways. One is frequency and the second one is phase modulation. Frequency and phase modulation. Already the second one is the frequency. Nothing but observe the waveform. For example, in some cases this is my waveform, in some cases this is the waveform, in some cases again this is the waveform. Observe here, the time period is less, time period is more. Here the time period is less. The time period is less means the frequency is more. Here the frequency is less. Therefore, here the frequency shifting is happening with respect to the message signal, positive and the negative peaks. The frequency is varying. The carrier frequency is varying according to the message signal. That's why it is called as a frequency modulation. Likely, phase modulation, for example, here from this point again it can start. Here, for example, again it starts. Here the phase should be occurs with respect to message signal. With respect to message signal, this is called as a phase modulation. Then this is under analog modulation schemes. Go for the pulse modulation. Here also depending upon the carrier shape, it is a continuous and it is not a continuous. Based on that, we are categorized. The pulse modulation should be analog modulation as well as digital modulation. Again, the analog modulation, remember PAM, pulse amplitude modulation, pulse width modulation, pulse position modulation schemes. Okay, that means our information signal is in the digital, but the carrier signal should be a continuous. On that situation, we go for the PAM, PWM, PPM. Pulse amplitude modulation, pulse width modulation, and pulse position modulation. I am giving next lectures combine one by one. What is PAM? How we can observe PAM amplitude, how the varying with respect to pulse of the message signal. Likely, digital modulation technique. In the digital modulation techniques, completely it's not discussing any about message should be carrier, message and carrier should be not in analog. Then it is some examples should be pulse code modulation, PCM, and the second one is delta modulation. In the pulse code modulation also we can explain some more techniques with respect to the filtering, prediction filtering, reducing the redundancy topics, differential pulse coding modulation. After that, we go for the delta modulation. Again, we can reduce the number of bit sizes, number of step sizes. So we go for the ADM techniques. These all are under coming digital modulation schemes. Therefore, once observe the types of modulation. The types of modulation should be a continuous wave modulation. Second one is pulse modulation. Again, the continuous wave modulation should be amplitude modulation, angle modulation, and angle modulation should be frequency modulation as well as phase modulation. Therefore, in terms of pulse modulation, we are looking about analog modulation, nothing but it depends upon the carrier signal shape, like a PAM, PWM, and PPM. And the digital modulation techniques we need to discuss about pulse code modulation and the delta modulations. This is nothing but a types of modulation. Then the last one is today what we discussed means introduction to modulation. In the case of introduction to modulation, we learn about what is low frequency signal, what is high frequency signal in graphical forms, and this is the first point. And the second thing we learn about definition of modulation, and third one is types of modulation. These things we discuss in the today's class very clearly. Next class, once you know about the modulation, what is the need for modulation? Where this modulation technique can be applicable and what is the importance of the modulation? We are taking some examples. Okay, with respect to modulation, this is the advantage. That is called as a need for modulation. In the next lecture, I am explaining very clearly about need for modulation. Thank you very much.